All right. So this is the corresponding rejection rule. So the first thing I'm going to write is the following. So in this case, we reject H0 if, right? Um, okay, this is the rejection rule. All right. So let me put this. In a box. Okay. Maybe I should have written. Okay. Let me call this equation here. This equation here, a star. Okay. Just for let to use. Right. Now for this question, what we need to do is, okay, first thing we need to do is to write down that what is given to us. We are told that sample size is 40. We are told that sigma is 30. We are told that mu zero is 200. And we are also told that this x bar, remember x bar is the sample mean, which is defined as, in this case, is defined as 1 divided by n times the sum I from 1 to n of xi, right? So this is going to be, given the data that's given to us, is going to be 8328.4 divided by 40. Okay. Now, if you do the math for this, you will get 208.221. All right, so these are the data that's given to us. N, sigma, mu zero, and x bar equals to this, right? Okay, now the next thing I'm going to do is I'm going to compute the left and the right hand side of this equation here. So let me start with the left hand side. The left hand side of star is root of n, which is root of 40, divided by sigma, which is 30, x bar, which is 208.21, and mu zero is 200. Okay, now if you compute this, right, you will get 1.731. So that's the left-hand side of star. Now the right-hand side, okay, to compute the right-hand side, we need alpha. Now, if you return to the question, it's saying to consider two different values for alpha, right? So suppose if alpha is 0.05, right, then the right-hand side of star, yeah, is going to be equal to Z 0.975, right? And this is going to be, if you read this off the table, this you will get 1.96. So the left-hand side is 1.731 and the right-hand side is 1.96. Clearly 1.731 is not greater than 1.96, all right? So the conclusion is that there is no evidence to reject the null hypothesis. In other words, we accept the null hypothesis, but normally people use this wording to mean there's no evidence to reject the null hypothesis because 1.731 is not greater than 1.96. Is that okay, guys? All right, and the next, I'm going to consider the case where alpha is 0.01 or 1%. In this case, the right-hand side of star, right, is going to be equal to Z 0.995, right? And this is equal to 2.576. Okay, and if you read this off the table, you will get 2.576. And once again, 1.731 is not greater than 2.576. So once again, the conclusion is that there's no evidence to reject the null hypothesis, right? Okay, guys, so this completes the first part of question 1. Are you guys okay with this or not? Let me know if you're not okay. I'm happy to go over again. Hello, guys. Are you okay? Or so it's just a matter of finding the rejection rule and computing the left-hand side, computing the right-hand side, and comparing them. And if this is greater than this, then you say that there is evidence to reject the null hypothesis. If this is not greater than this, then you say there's no evidence to reject the null hypothesis. All right. Are you guys okay or what? Hello, guys. Talk to me, please. Hello. Okay. Thank you. Thank you. All right. So that's part 1 of question 1. Now part 2 of question 1 is about testing mu equal to 200 versus mu greater than 200. So we need to go back to the formula sheet, right? This is the formula sheet I gave you last week. Now, of these 3 tests, the one that corresponds to mu equal to 200 versus mu greater than is this one, right? So the rejection rule is this one. So I'm going to use this as the rejection rule in order to do part 2 of question 1. Right? Okay, so let me do that. Okay, so this is sorry, question 1, part 2. So the rejection rule is if root of n divided by sigma, yeah, is greater than, you remember the rejection rule, is greater than Z1 minus alpha. So let me put this in a box once again, right? And let me call this star once again, okay? So we know from what is given to us earlier that n is 40, sigma is 30, mu0 is 200, and x bar is 208.21, right? Okay, now, so the left-hand side, so the left-hand side of star, this is star, right? I'm going to compute the left-hand side first. It's going to be root of 40 divided by sigma. X bar is 208.21 minus 200, right? And if you work this out, you will get 1.731. Okay, now in order to compute the right-hand side, we need to choose alpha. So let's take alpha to be, first of all, let's take alpha to be 0.05. In this case, the right-hand side of star is going to be Z 0.95, and this will be 1.645. So this is the right-hand side, and this is the left-hand side. Okay, so you can see clearly that the left-hand side is greater than the right-hand side. All right, so the conclusion here is that there is evidence to reject the null hypothesis, right? Okay, all right, so that's if alpha is 0.05. Now let's see what happens if alpha is 0.01. Okay, in this case, the right-hand side of star is Z 0.99. And if you read this off the table, this will be 2.326. Okay. So in this case, 1.731 is not greater than 2.326. So the conclusion here is that there is no evidence to reject the null hypothesis. All right. Okay, guys, so this completes part two of question 2. Okay, are you guys okay with this or no? Hello, guys. Hello. Talk to me. Are you guys okay with the part 2 of question 1 before I do the next question? Hello. Are you okay? All right. Okay. All right. So the next question I'm going to do is question. So I'm done question 1. The next is question 2. So here the question says that you have 10 data points from a normal distribution with the variance equal to 3, x bar equal to 0.7. And the first part is to test mu equal to 0 versus mu greater than 0 at 5% significance level. Right? All right, so let's see how we can do this. So clearly this question, so this is question 2, part 1. So this question is, once again, we are assuming that the population variance sigma squared is known, right? Can you guys see? I know it's not clear. Maybe it's better now slightly, all right? So we are assuming that the population variance is known. So the rule that we need to use, because you're testing for mu equal to 0 versus mu greater than 0, right? The rule that we need to use is this one once again, right? Because we are assuming once again that the population variance is known, and the corresponding rule for this hypothesis is this one, right? Okay, so let me write it down, the rule. So we reject the null hypothesis if root of n okay, right? So now once again, let me put this in a box and call this star. Okay. All right, now let's write down what is given to us, right? The n is the number of data points is 10, right? And we are told that sigma squared is 3. We are told that x bar is 0.7, right? And we are told that mu 0 is equal to 0. So these are all the data that's given to us. So in order to perform the test, what we need to do is to compute the left-hand side and the right-hand side. So let's try to do that. So the left-hand side of star, right, is gonna be root of n, which is root of 10, divided by root of 3 times x bar, which is 0.7 minus 0. And if you compute this, you will get 1.275. Now, the right-hand side of star. Now we are assuming 5%. So alpha is 0.05, okay? So the right-hand side is Z 0.95, which if you read from the table, it will be 1.645. All right, so this is the right-hand side and this is the left-hand side. And clearly 1.275 is not greater than 1.645. So the conclusion is that there's no evidence to reject the null hypothesis. Okay. Are you guys okay with this or not? Hello guys, talk to me. Why are you being quiet today? Are you guys okay with part 1 of question 1? Question 2, I mean, question 2. All right, thank you guys. All right, so, okay, let's go to part 2 now. Part 2 is asking you to calculate the type 2 error probability when mu is 1 and mu is 1.5. All right, now, so that's what I'm going to do here. So I'm going to show you here. I'm going to show you how to compute the probability of type 2 error. Remember, we talked about the type 2 error last week. I mean, if you haven't watched the video, please do so. So the probability of type 2 error is the probability of accepting the null hypothesis when H1 is true. Right? Right. Now let me go back to part 1 just briefly. This is the rule for rejecting the null hypothesis, right? So the rule for accepting the null hypothesis will be the opposite of this. In other words, yeah. So this is mu greater than 0. This is the alternative hypothesis. And this is the opposite of this rule. This is the rule for rejecting, and hence this is the rule for accepting, right? Okay, now I'm gonna put in everything that I have. N is given to us, right, is 10, right? And sigma is root of 3. And mu0 is 0. And alpha is 0.05. So this is going to be 1.645, given mu is greater than 0. Okay, guys. So I just subbed in all the numbers we have, right? All right, now we are asked to compute this. You should return to the question. You should go back to the question, guys. It says it's asking you to compute the type 2 error probability when mu is 1 and when mu is 1.5. Right. So let's first consider the case that mu is equal to 1. Right. So in this case, the probability will become okay. All right, guys. Right now, in order to compute this, I'm going to use a trick. And the trick is as follows. I'm going to write x bar as x bar minus 1 plus 1. The reason I'm doing this, I will explain why in a sec, why I'm doing this, right? And then I'm going to take the 1 here to the right-hand side. So okay. All right. Now, do you guys recognize this term? Have you seen something before, something like this before, or no? Hello, guys. Talk to me. Do you? Okay. Let me write. Let me try to refresh your memory if you don't remember. Okay. If this is a random sample, yeah, then yes, you're right, George. Yeah, you're right. You do remember. Thank you. Thank you, George. If this is the result I meant you to recall. This is a result I talked about on the video on normal distribution. If you don't remember this, please go and have a look at the video once again. So it's basically says this: if you have a random sample from a normal with these parameters, then this guy has a standard normal distribution. So this, what you have here is exactly of this form because we are conditioning on mu being 1. All right, so using this result, we can argue that okay, you follow me? So I have I have used this result to argue that this has the standard normal distribution, and hence this probability is equal to this. And we don't need the conditioning anymore because we have used the conditioning to argue that this has the standard normal. So hence the conditioning is not needed anymore, right? Okay. Okay. And this, if you compute this off the table or using R, this is what you will get. So the type 2 error probability, when mu is 1 is equal to 0.43. Are you guys okay with that? Let me know if you're not okay. I'm happy to go over again if you're not okay. All right. So that's when mu is 1, right? Now let me do it again, the same calculations when mu is 1.5. So this is when mu is 1, all right? Now I'm going to start again when mu is equal to 1.5. Okay, so in this case, this guy here will become the probability that okay, yeah. And now, once again, I'm going to use the same trick I used in the previous step, previous part. I'm gonna take away 1.5 and add 1.5. Okay. All right, guys. All right. And next, I'm gonna take this number here to the right hand side. All right. So this will be the probability that okay. All right, now using the same argument that I did, using this argument here, right? We can argue that this guy here, condition on the population mean being equal to 1.5, this must have the standard normal distribution. Okay. Okay, once again, we don't need the conditioning anymore, right? This is equal, okay. Now this is the 5. Okay. The reason we don't need the conditioning is because we have used the conditioning to argue that this has a standard normal, right? So hence the conditioning is not needed anymore. Okay. Okay, guys. So now if you compute this off the table or using R, this is what you will get. So the type 2, so the probability of type 2 error when mu is 1.5 is 0.14. Okay, guys. Let me know if you did not follow this. I'm happy to go over again. Okay, the next part is part 3. So let's go back to question 2. Okay, part 3 is saying that assuming that the sample mean remained the same, how large would the sample size need to be in order for H0 to be rejected in favor of H1? Right, okay, now let me show you how to do this. Now going back to part 1, remember this is the rejection rule. So to do part 3 of question 2, right? What the question is asking you is basically, what should n be? So n, we don't know what n is. Sigma we know is root of 3. X bar we know, X bar is, sorry, what was X bar? It's 0.7, yeah. Mu 0 we know was 0, right? And this we know was 1.645, right? So basically the question is asking you, if this is the case, what should n be? So it's basically a question. So it's root of n greater than 1.645 times root of 3 divided by 0.7, right? And this implies, now if you square both sides, this will be n greater than 1.645 times root of 3 divided by 0.7. Okay. And this, if you compute this using a calculator, this will be 16.5675. Okay. Now, n cannot be a decimal number. It has to be an integer. So this is the same as saying that n greater than or equal to 70. All right, so this is the solution to part 3 of question 2. You guys okay with this or not? Let me know if you're not okay. I'm happy to go over again. So basically using this rejection rule with the same sample mean, the same mu 0, with the same alpha and the same sigma, the question was to find what n should be, right? And it turns out that n must be greater than or equal to 17. Right, guys. Any questions before I do the next question? Before I go to question 3. Hello, guys. Talk to me, please. Are you okay with this or no? Yeah. Thank you. All right. So I'm done with question 2. All right. The next question is question 3. So here it's about light bulbs, so the mean life of light bulbs. And it says you have 250 light bulbs, and the mean lifetime is this, the sample variance is this, and you're trying to test this versus this at 5%. Okay, in this case, I mean, if you read this question, it says clearly that the population variance is not known because it only gives the sample variance, which is this number, right? So which automatically means that the population variance is not known. So going back to the formula sheet, you cannot use any of these formulas because we are assuming that the population variance is known. So none of these formula apply. Okay. But if you remember this is another thing I gave you last week. This is the case where the population variance is unknown. And these are the corresponding rejection rules corresponding to the 3 sets of hypotheses. So when mu is equal to something versus not equal to, the rejection rule is this one, right? So I'm going to use this rule to do question number 3, right? All right, so let me show you. So this is question 3. So we reject the null hypothesis if this. Okay, if this is the case, right? You guys follow me, right? So it's very important that you choose the correct rejection rule. But if you choose the incorrect rejection rule, everything you do will be wrong. All right. So you have to read the question very, very carefully and choose the rule that is the most appropriate one. Right. All right. Okay. Okay, guys. Now the next thing I'm going to do, I'm going to compute the left and the right hand side of this. Before I do that, let me write down what is given to us. Right. We are told that n is 250. We are told that x bar is 1794.6. We are told that this is x bar. S squared is the sample variance, is 2484. We are told that mu0 is equal to 1800. And we are told that alpha is 0.05. All right, so this is everything that's given to us, right? Okay, so what I'm going to do now is I'm going to compute the left-hand side. So the left-hand side of star is going to be root of 200 divided by the root of 2484. X bar is 1794.6 minus mu0 is 1800, right? And if you work this out using a calculator, this will be 1.713. Right, so that's the left-hand side. Now the right-hand side, we know alpha is 0.05, so the right-hand side of star is going to be t, n minus 1 is 249. 1 minus alpha by 2 is 0.975. right? And if you read this off the table, you will get something like this. Now, by the way, this you need to read this off the T table. Remember, last week I talked about how to read the T table, right? Oh, I think it was well before last week. Now, 249 may not be in the table, so you need to, if this is not in the table, then you will need to find something that is closest to 249, right? And that value will be close to this, right? Okay, all right. Now, I assume you know where the tables are. The tables are in the, you should go to the post website, and there's a link called formulas, and you should click on that link and go to the very bottom of the link. You will see how to read this, all right? So this is the left-hand side is 1.713, the right-hand side is 1.96, and clearly this is not greater than this. So the conclusion is that there is no evidence. There's no evidence to reject the null hypothesis. Okay, guys, are you okay with this or no? So this is the solutions to question number 3. Yeah, thank you. All right, the next question I'm going to do is question number 4. So let's go to, I'm done with this. Question 4 is this one right here. You have a standard deviation of 8.7, mean at least 250. The sample size is 20. The sample mean is this, and you're trying to test this versus this, right? Let me see this, or maybe it's not bright enough, I don't know. Okay, I'm trying to just, okay. All right, so in this case, in this question, we are assuming that this population standard deviation is known and is equal to 8.7. So the rule for testing this versus this has to be this one, right? Remember, this is the case where the population variance sigma squared is known. And in this case, the rule for testing this versus this is this, right? So hence, okay, let me write down the rule first. So the rule, so this is question number 4. Question 4, part 1. So we reject the null hypothesis if root of n divided by sigma yeah. So let me put this in a box. Yeah, and let me call this once again star, right? Okay, so part 1 is asking you to perform a test at 5% significance level, right? So let me show you how to do it. I mean, we have already done it enough times. I mean, so let me write down your n is 20, yeah? Your sigma is 8.7. Your x bar is 252.96. And your mu0 is 250. And your alpha is 0.05. This is everything. This is all the data that is given to us, right? So the first thing I'm gonna do is I'm gonna compute the left-hand side of star. So that's gonna be 25296 minus 250. Now, if you work this out using a calculator, this is what you will get, right? 1.521. And the right-hand side of star is, because alpha is 0.05, this will be Z 0.95, which I'm sure you know is 1.645. So this is the right-hand side, and this is the left-hand side, right? Okay, so clearly this is not greater than 1.645. So the conclusion, once again, is that there is no evidence to reject the null hypothesis. All right, so this is part one of question 4, right? Are you guys okay with this? Hello, talk to me, guys. Yeah. Okay. Now, part 2. Let me show you part 2. Part 2 of question 4 is asking you this. Calculate the probability that your test will correctly reject H0 when the true value of the mean is 255 and also 257. All right, now I know I'm running out of time, but let me show you in the short time I have. Now, to do, basically what it's asking you for is the following. It's asking you to compute the probability of reject H0 when the true value of the mean, the population mean, is 255. This is what the question is asking you, right? Now this, we know this is the rule for rejecting H0. All right, now putting in the value for, remember n was given as what, 20, right? And sigma was 8.7. X bar, leave it as X bar. Mu zero was given as 250. Greater than this guy is 1.645, given that mu is 255. So this is the probability that you're asked to find, right? Now, to do this, you need to use the same trick I applied in question 2. Remember, in question 2, in question 2, I applied a trick like this. I'm going to change this to 255. The reason for that is because the true population mean is 255. And then I'm going to add a 5 in order to make up for this. Do you follow what I'm doing? It's the same trick I did in question 2. All right, now the next, I'm going to take this term here to the right-hand side. So this will be the probability okay, like this, right? Now, okay, using the same argument that I did previously, you may recall, just a few slides ago, I showed you you remember this argument here. Do you guys remember this? That if you have a random sample from this has the standard normal. So using this result here, I can argue that condition on mu equal to 255, this must be standard normal, right? Okay. So using this argument, I can argue that this probability is the probability that a standard normal variable is greater than 1.645 minus 5 times root of 20 divided by 8.7. We don't need the conditioning anymore. Now this you can write as 1 minus the probability that the standard normal is less than or equal to 1.645 minus 5 times root of 20 divided by 8.7, right? And this you can write as 1 minus phi, yeah, at 1.645 minus this. Now you can read this off the table for the normal distribution. And if you do that and take away from 1, this is what you will get. All right, so this is the probability that of rejecting the null hypothesis when the true population mean is 255, okay? And similarly, you can do this, I mean, this is for when it's 255, and the question is also asking you to do the same thing when the true population mean is 257. I'm sure you can do that by yourself, right? Okay, guys, so I'm sorry I had only time to do the first four questions. The 3 remaining questions, I'm sorry I'm not able to do them today, but I will post the full solutions to all 7 questions in the website tomorrow. Okay, so you'll be able to see the typed solutions, the video solutions, and the handwritten solutions for all 7. All right, and now one final request. I know I've been sending you thousands of emails. If you haven't completed the unit evaluations, please could you kindly complete it ASAP? I would be most grateful for your comments, right? Okay, guys. So have a great morning. Yeah, it is the power. Yeah, John. Yeah, you're right, John. Yeah, it is the power of the hypothesis, John. Yeah. But we did not talk about power in this course because that's beyond the scope. I think next year, in year 2, you will talk about power, what power means. Yeah. All right, guys, have a great morning, great evening, or great afternoon, wherever you are. And please feel free to contact me any questions you have by email, Skype, Zoom, or phone. You know my phone number, 0161-273-2941. Okay, guys. Sorry, Lynn. Sorry, I don't know why I sent you again, but sorry, my apologies if I send it to you again. But if you could ask your friends to complete that too, I would be grateful, Lynn. Okay, please ask all your friends to complete it too. Thank you.